My name is Greg George, and I'm an applications engineer with 3D Systems. For my portion of today's presentation, I'm going to do a brief PowerPoint discussing Freeform here, as you see on this slide, and then we'll do a live presentation here in a moment. But before, I wanted to explain a little bit about Freeform and what it is to get us started here. So Geomagic Freeform, as you can see from the slide, it's the industry's most comprehensive organic hybrid design software on the market, enabling you to solve complex precision design and manufacturing challenges. So it's a high-end organic modeling type application that's designed around manufacturing. And that's where I feel like the differentiator with Freeform is and other softwares on the market. So when we sculpt something with Freeform, we're usually trying to create it, a physical object, where some other softwares on the market are not designed for actually manufacturing, or they're usually designed around creating visualizations on computers for animations and things like that. So Geomagic Freeform, the product, is actually both a hardware and a software component to it. So as you see here on this slide, I have a haptic device on my desk right now that I'm going to be using during this presentation to run the software. And that haptic, it's like a 3D mouse, but it has a touch feedback to it. So when I actually put the stylus on the part virtually in the software, I can feel it with the stylus in space. So as you can see in the bottom right hand corner there, I have a video of the haptic in action. And you can see how for highly organic applications like this, a haptic would be very beneficial to have over just using a mouse. So as the slide shows, for ultimate expressive freedom and faster modeling, this gives you like a hand feel, a personal touch to the modeling application, and delivering free form motion and physical sensation of sculpting in a virtual environment. So Geomagic supports mesh formats as well as scan data formats. Like we talked about earlier here, we can bring in scan data from 3D scanners and work off them directly without having to convert them to anything else using this haptic touch. Now, Rapid 3D has a couple of these haptic devices available at their facilities for usage with trials and stuff. So if you need to get your hands on it, obviously that's the best way to understand how a haptic works, is to actually touch and feel it for yourself to see how beneficial that is. So what can you do with Freeform? Uh, as you see on the right-hand side, people using Geomagic Freeform have a wide range of applications. So creating fast design iterations, design manufacturing ready models, um, designing complex shapes with parting lines and different things like that. We can extract parting lines from the highly organic surfaces, or even repairing complex geometry, no matter the design software that you use to create it. And like you see on the right hand side, these are all products that were designed in Freeform. And I often like to say in these presentations, you've seen objects that are created with Freeform. If you just go to your local department store, like a Walmart or Target, and you go down that toy aisle, or you go down any of the consumer uh, aisles where you have, like, for example, this razor, many companies are using this software to create those objects. And and you can see many of the toy companies are using Freeform to design those shapes as well as the medical modeling applications too, as you can see here. How does Freeform actually do this? I wanted to dive into a little more of a technical side of things first before we move over to the software and explain, how Freeform is able to accomplish this, right? How does it differ from a CAD package, right? Well, the first thing is it's a multi-representational modeler, and most people, when I say that, don't understand what I'm talking about. multi-representational, but that's the best way that I've found to describe it. So with 3D modeling, there's actually a bunch of families of 3D models out there. That's what I like to call them as well. Most people, when you say 3D modeling, are thinking of two main categories. They're thinking of either a CAD package, if they come from the manufacturing environment, or they're thinking of animation stuff that like you see in the movies where people are doing CG and things like that. So those two are actually two different families. So CAD objects, the CAD origins 3D model families, really centered around NURBS surfacing. And those are non-uniform rational B-splines. And those work really well for prismatic shapes. And that's where most manufacturing is done to this day. So if you own SolidWorks, CATIA, NX, all those different CAD packages, are very good at prismatic shapes, but where they struggle is an application like we're talking about today, where you take highly organic shapes and work with those. So that brings me to voxels. Freeform is one of the very few softwares out there that actually does voxel modeling, and voxels are volumetric pixels, and I use that picture there to show like a stack of cubes. And the picture of the hand is actually a voxel object. Those cubes are just very, very, very small. And what we do is we create a model based off of those stack of cubes. So those are voxels. And then to the right of that, polygon meshes are what the scanner today that we used scans in. Primarily, they scan in a point cloud, which is a bunch of 3D measurements, and then the software will connect those 3D measurements together into triangles because that is the easiest form of 3D model to create coming from a data collection device like a laser scanner or a white light scanner like we use today. So what we do, and we'll do later today in the presentation portion, in the demonstration portion, is take that polygon mesh and fill it with voxels. So it's a very easy conversion process from polygon meshes over to voxels, and we'll do that again here in a minute. And then another one that Freeform works in is subdivisional surfaces. These are used a lot in the animation world. A lot of the little children's cartoons that you see, Octonauts and different things like that, all those models are designed with subdivisional surfaces, which they're kind of a different family. It's like a hybrid of like polygons and CAD in a way. That's the way I like to think about them. Today, we're really not going to utilize those, but Freeform models in those as well. So we can work with all of these in one space and even interchange between the different model family types. So today's process is going to look a lot like this. We've captured data, and we saw that earlier, and we're going to bring in that scan data directly into Freeform. We're going to fill it with voxels. It's like pouring sand inside of that hollow shape that we've created. And then we are able to utilize a ton of different sculpting modeling tools inside of Freeform to create a shape that then we can go to additive manufacturing if we want to. So you can see here that we can go print that object. This is an overview of that whole workflow that we're going to talk about. So now we'll go ahead and shift over into the Freeform product, and I will switch screens here in just a second. Okay, so here is Geomagic Freeform, and as you can see on screen that I have a scan of this hand here. And what we're going to do is go ahead and create a brace around this shape, just like the image that we used for the invitation to the webinar and in the PowerPoint. So I'm going to create a very similar brace today. And as you see, when I bring in a scan, it's over here on the right-hand side. We color the objects different colors based on what type of model they are, going back to that family comment earlier. So this is a polygon mesh. It's a purple object. So it is a triangle object. Now, just to show you how easy it is to convert that over to voxels, I can come over here and click on it and come over to Mesh Utilities and say copy to clay. So clay is the terminology that the software uses throughout to describe a voxel object. And with voxel objects, When I convert it over, I basically have the option to uh, adjust the edge sharpness. Now the edge sharpness is the voxel size. So remember that stack of cubes that we showed in there. It's basically the resolution of those cubes. And in this instance, what I'm going to do is say that they need to be 0.5 millimeter cubes, and then I can hit apply. So now the software is going to convert that over, and you'll see that it hides the mesh and then shows the object as a voxel object now. Now we're able to work with it. So the first thing I always do with a workflow like this is it jumps you right into reposition piece automatically after that. The software knows that most of the time when you want to convert an object, the next thing you want to do many times is move it around. That's what the reposition piece does. So with the haptic device, again, I have this connected to the software and I'm going to be using it the entire time today. I can grab this model and I'm using the haptic to just move it around in space. Now that's just changing my view oriented to the object. But if I hit F2, which is my front view, it takes me to this XYZ home view, and you'll see that it's on an angle. It's like my arm is laying on a table. Now today, what I want to do is I want to rotate that to an upright position. So using this, I can actually grab using this tool, and I can just move the piece around with the haptic, and then I can even come over and you know turn off the move constraint only, and I can free move it around as well, where I can grab this and put it wherever I want in space, and I'm just holding it with the haptic and putting it wherever I want. So I can do that, or Freeform is both very loose or very specific as to how it works. So you can see this dialog here that I have open. I can come in and I can say I want to rotate about Z, and I can hit the plus minus here if I want to, or I can even type in a value. I can say I want to rotate that 90 degrees, and I want to rotate this 270 degrees, and I can move it around. And then I can even use those options to kind of bump it and rotate it. So if I just want to bump it over, and I can adjust my translation step. And then what I like to do is I use the arrow keys and kind of rotate around the part and make sure that it is where I want it to be. So if you see I want to bump it forward a little bit, I can do that and position it. I like to position it here, and you'll see why here in a minute, that I'm going to put my 0 point at that location. So we'll just come in and bump the X and that there, right there. So I'm going to go ahead and get out of that tool. So now that I have it positioned, the next step is to jump into some of the tools that we have available, sculpting tools, to manipulate this voxel object before we go ahead and create the brace. So one really powerful tool that we have is this option to bend and twist, believe it or not. So when you're scanning a person's anatomy, while they do their best to hold their anatomy in the same position, sometimes it's difficult to get them to hold it in a nice straight posture. Now this one is a great scan, but what I'm going to do is go ahead and show how I'm going to create a plane from the top view, and then I'm going to say I want to create it through the origin flat to my view like that. So I just put it through the origin flat to that view, and it's right through the wrist. Now if I come over to the bend and twist, the bend and twist tool by default, you can actually just click somewhere on screen and select where you want to bend the part. But today what I'm going to do is just be a little more precise and select the plane that I just created. It's a very precise plane. I can then change the volume that I want to work with, and even change the extents of the bend and move that around. And once I've created the envelope of the area that I want to bend, I can toggle over to the twist portion. And you will see here that one side will turn green, and that is the side that we're going to bend. So this again is a great time to kind of use your predefined views here, and then you can actually grab and bend the object. Now obviously you can create some pretty crazy geometry here. But not just bending, I can also twist. It makes some people feel real awkward here. But you can twist that object as well. So what I like to do is I'll look at it from a few different perspectives. I'll just hit undo to those changes, and then we'll toggle back into it again here. And what I like to do is move with more precise movement than that. So I'll rotate to the side, and if I'm trying to correct it in this direction, I will, just barely bend it and then come in and type in a specific value and say that, okay, that needs to bend 5 degrees, and I'll just twist it just a little bit. And keep in mind, the more you twist it, the more you modify it, the farther away it's going to get away from their original anatomy. So if I go ahead and hit apply, it'll accept those changes and bake in the changes to that model. So now that that's finished, you'll see that the green goes away and it's done. And I can get out of the command, and then I'll go ahead and hide my plane. So now we are ready to start creating the brace. Now, if you remember the image that we had from the presentation earlier of the turquoise brace, one thing that we had is the fingers were filled in. So what I'm going to do is go over how to do that. This is just one approach. There are many different ways designers might approach creating the fingers for this. And in this part is a little bit tedious, so it'll take me a second, and I'll kind of dictate how we're doing it along the way. But just bear with me. It'll make a lot more sense here in a second when I show you why I'm drawing these curves here on the surface of the part. So while I'm doing that, I'll just kind of describe the process as we go through here. I'm essentially drawing 3D curves directly on the surface of the part. So if you know CAD well, you'll know that these 3D curves are actually 3D splines. They're CAD-like 3D splines that I'm drawing right on the surface of the part. And I'm using the haptic. I can feel it underneath the whole time. And I can actually come in and click and drag these and manipulate them and move them around and put them wherever I want to. And I'm just going to go ahead and draw that one more time because I didn't snap it to the surface. Actually, this one too. So I'll go ahead and redo those. But I can feel, as long as I stay on the surface of the part like I'm doing right now, I can feel the surface right there. Now I'll just go ahead and draw that last one more time. And this will make more sense here in a second why I'm drawing them this way. So I'll go ahead and draw some curves around the knuckles. And this works better if you don't have a bunch of coffee before you use the haptic. So there you go. And each time I'm just using some shortcuts to close the curves and end the curves. And then I'm going to connect these curves together into like a cage. And that's what leads me to show like the method that I'm going to use here. So I'm going to close those curves and I'm going to create this cage. And then I can also use this tool that will extend the curves past the ends of the fingers. There we go. Like that. Then I'll toggle back over to my draw curve tool. And you can see that I could come over here and connect these together. And this is where having the haptic is super helpful, uh, not just for drawing the curves, but even rotating the part around very easily and intuitively. You can see that I can quickly just come in and draw things in space And if you're not trying to show it during a presentation like I am, it's actually quite easy to do. And you see, I can actually just draw curves out in space using the haptic. And you see, I just drew a 3D curve out in space there. But you see, now that I have that, you can see that it looks like I just created just like you would have like a fin to swim through water. So what I'm going to use now is this curve network to clay. And this is where CAD comes in handy in the background, because we're actually using CAD tools to create a solid body that then we're going to voxelize. So I'm going to go ahead and click on that curve network, and I'm going to dictate what resolution I want those voxels to be. I'm going to use that same half millimeter, and then hit apply here. And then it created a new piece, a new separate piece of a voxel object, and I'm just going to collect those curves just for housekeeping purposes into a folder. And you see that we created that directly over top of the other object. Now, once I have this, I can go ahead and merge these objects together and start to work on them. But before I do that, what I'm going to do, this is one thing that I found worked really well before, is if I use the Tug Tool, we have this command called the Tug Tool. It basically has this area of influence, a sphere, where I can click and drag on an area. And I'm going to actually click and drag on the finger, not the web shape that I created. And I can change the volume of influence. So I'm just going to up it and make it a little bit bigger and extend the finger. Now we have a bunch of different ways I could extend that finger. I could use the lattice tool. I could use so many other tools, but I'm just going to do that for housekeeping purposes. You'll see how I create this here in a minute. But this Tug Tool works anywhere. Like I can just click and drag and manipulate the piece just like it's clay, right? I can click on that finger and move it around and manipulate it. It's easy to create a mess in here using it, but in the right hands, this tool is extremely powerful. So now that I have those two objects in space, I'm going to go ahead and select them both, and then I'm going to come over and I'm going to say, I want to Boolean these together, combine them in as a new object over in my tree. So I have the original piece, and then I'm going to Boolean the two together or merge them into a new object. Now, as you can see, right out of the gate, the first thing I might want to do is go ahead and clean up some of these areas where the anatomy bisects the paddle area that I created, for lack of a better term. So some things you can do is I can grab this hot wax tool. This is one of my favorite tools. You can kind of come in and you can kind of smooth and melt areas. And this works really well for smoothing out areas. But for this specific task, what I'm going to use is a smooth area. Smooth area allows you to click an area and smooth it, right? So if I just come in and hit smooth, but you see it didn't completely remove that area. There's another hidden tool right here inside of the smooth area is this defeature. So if there's areas that have so much topology that you want to just kind of remove that whole spot, you can click defeature and you see how it removes that area altogether. And I can use shortcuts and kind of shrink down the size of my stylus as well, and then remove these different areas. And it works all the way around the part. So I'll use this defeature functionality quite a bit. And if I just come over here, and I could smooth that out a lot, or I could just run defeature here. On the side area, I might go ahead and run smooth. So this area right here, I might just reduce my stylus size and then just hit smooth. And you can adjust the level of how much it smooths. See that? And the same thing goes for here. Just paint that. And then this is where, again, the stylus, there's a lot of hidden times where it's just super helpful to be able to just grab the haptic and touch right there and say smooth that, you know? So having the haptic connected to a piece of software like this is just very beneficial. Um, so if I come in here and that one, I'm just going to say defeature because I want to go ahead and remove that whole divot area and then smooth it out and fill it all. We'll see what it looks like. If I don't like it, I can always undo it. So this area, I'll go ahead and select that and then defeature all these areas. And then these others I will smooth as well. So you can see how easy it is to create this. And the reason why we're creating this is this with this type of brace, sometimes it's nice to create a brace that's not going to hold each finger independently. It's just going to give them room to move those about independently, right? So that's why I'm just showing a more elaborate workflow than some of the other times that I present the software. I like to mix it up and show different options that are available. So you can see I'll go ahead and use defeature in this instance. And there we go. Now, I can spend more time coming in and touching it up. You know, I can come in with hot wax and smooth some of the transition areas and all that. But for the sake of today and just trying to keep everything moving along, I'll just speed it up a little bit. So the next thing I'm going to do is I'm just going to retrim that top area. And this is where the software utilizes, again, more CAD tools. I can go ahead and throw a plane normal to my view, and then I can come in and sketch directly on that plane. And I'm just going to trim off that top area all as one. So you see I'm going to go ahead and hit N there and then draw another curve around that way. And then I'm going to use what we call wire cut clay, which wire cut is basically just an extrude. If you've used a CAD package before, I can select my sketch and then I can extrude a shape. And in this instance, I'm going to say I want to extrude cut. And then it will cut that top area off and just cut a nice clean shape. And that's part of the reason why I extended it past. And then another hidden thing that's really nice is so far we've been sculpting from the outside, you know, where I'm touching the part from the outside. But you can actually pop to the inside here, and I can actually pop to the inside and go all the way around that shape there with my haptic and quickly select that top edge and then hit smooth. And it's almost like adding a fillet to that top boundary of the shape. So that's part of the reason why I did that, where I extended past, trimmed back, and I created this like paddle type shape. So now we're going to transition into the section where I'm going to draw the actual shape uh, of the brace on the surface of the part. I'm going to trace out that trim line. And to do that, I'm going to go back to that same draw curve tool, and we'll just start right here. Now this can be a little complicated to do when you're trying to draw, you're trying to figure out where you are in 3D space and draw this shape. I'm going to turn on fit to clay as well. So what I'm going to do is I'm just going to go around, and it helps sometimes to look at your own hand to make sure that you're drawing in the same exact spot that you might want to draw. Or even look at the picture of the final brace that I have in the presentation earlier to kind of know where to trim. See, so I'm just going to draw the outer perimeter of the shape of the brace that I want to create all the way around the part. And you don't have to do it all in one like I'm doing today. You can draw it in separate curves if you need to. But for today's, I'm just going to try to draw it all in one curve all the way around the outer surface. And this is what I'm talking about when it's possible to get confused as to where you want that brace to go. So you see, so I'm going to come all the way up here. I'm going to leave an opening for the brace. And then go back down to the other side. And I'm going to come down. kind of open up and come back up over the back of the hand here. And we're going to create a small little area around the back of the hand to support it. Then, so I'm going to make it a little different from what we did from the screenshot in the presentation. And we'll tuck it, come back around here. There. So you see how I went all the way around, and that's going to be like my outline for the entire brace. So I've done a lot of different brace presentations, and we have some real easy tools to create basic braces. But what I'm doing with this one is I want to create a really neat looking shape that's going to go all the way around the part. So I'm going to do it a little bit different today. What I'm going to do is take this whole object, and I'm going to use the ridge tool first of all. The ridge tool, we'll just close that dialog because we don't need to see it right now. The ridge tool is a real neat tool where I could select a curve and fit a shape. It's like having a sweep, but the sweep follows normal to the surface. And what I mean by that, I'll just go ahead and click it and you'll see the preview. So I have it set for a square shape, and there's built-in shapes that are already in the software. So you can even make your own based on a selected sketch. But in this instance, I'm using a square, and you can adjust in those settings that popped up earlier. So if I click that, I can adjust the square's dimension, and I basically set this to be a 1 mm thick piece, and I set it to bisect the interior of the part as well. And you'll see it follows normal to that surface. So this becomes a trim line. So I'm going to tell it to create it in its own new piece. And instead of 0.5 mm, because this is real thin and I said 1 mm, I'm going to go ahead and make it 0.2 millimeters. I'm going to make it a finer resolution. Because if you think about it, if my voxels are 0.5 mm and I make this 1 mm, that's only 2 voxels wide, and that's not a really good way to create that shape. All right, so now you see I have this ribbon that goes all the way around the outside. I'm going to go ahead and save the part, because I always do this when I'm working on a larger project. It's just save. At different stages throughout the project. Now, once I save that, I'll go ahead. I want to create an offset of the anatomy. So I have a shortcut for the offset tool because I use it quite a bit. Say create offset piece. I'm going to offset the piece 3 mm because that's how thick I want my brace to be. So once I create this offset, you will see that I can then boolean my ridge away from that offset. Oops, I offset the ridge, so I'm going to undo that real quick. And then I will offset the entire object. So now that the undo is done, I'll go back over to the main object this time and offset it. So I'll hit offset piece, 3 mm, not offsetting the ridge this time, and it will calculate. So this takes just a second to calculate. So again, what I'm going to do is offset the entire shape, 3 mm, boolean the original shape away from the offset, and boolean the ridge away, which will leave 2 pieces. And then we will select one of those pieces and delete the other to create the brace. So if that doesn't make much sense, you'll see how it works out here in a second. And there we go, it finished. I hit OK, and you'll see that I have my positive offset piece created. So if I just hide that, you'll see the other piece, and you'll see the new piece right there on top of it. So now I'll activate the original piece, Boolean, remove from, positive offset. Now, Go ahead and hide that. Now we'll take the ridge, activate it, remove it from positive offset, and then turn ridge off. So now you see that we have these little valleys in there. Now I can come over to select clay. And I'm going to use the seed select tool. Oops. Got to activate it first. Seed select. Click on this piece. I'm going to inverse, delete. So now you see that we've created this brace that fits exactly to the shape. And again, we're doing this all on voxel objects essentially directly off of scan data, right? So I'm not having to convert anything to CAD, but yet I'm using the best of CAD tools to help me model directly over someone's anatomy. So if you want to see it in position, you can see here is the other object directly over top of it. And if you want to turn on the original hand, still has extended fingers, but you can kind of see it in context there. So the next thing I usually do is I'll go ahead and utilize this shape and cut away some areas of relief. Sometimes you need vent holes or areas of relief and things like that. In order to do that, I usually will come over and just draw some shapes directly on that original anatomy and then use those to boolean away. So if I just come in and I have one object showing on top of another, right? But I'm drawing on the underside. I'm drawing on this object right here, and I'm just using that other one as a guide to see. So once I draw that shape, I can use tools like this emboss with curve, and I can select that curve and select the interior of it. And I can use images to emboss the surface of that underlying surface. You could add positive embosses, negative embosses, or even do what I'm going to do here today, where I'm going to take that embossed shape and these lines, and I'm going to offset them 4 millimeters higher than the brace. Now, once that finishes, I'm going to turn the brace off, and you see that I used the underlying geometry to do so. Now, if I just come back over to this shape and then boolean it from my brace, I'll go ahead and turn that geometry off, and now you see that I've created vent lines throughout that surface. Now you can use any raster image to do that with. So I just used, these are black lines that I used, and I made those in Photoshop. And you can bring that image over and just load it into a library of raster images, and we use the grayscale to offset the surface of the part. Now once we do this, I'll usually come in and change my clay coarseness, which is my voxel resolution. I'll raise it up to like a 0.2, because a lot of times I like to add a little bit of texturing to the surface as well, which is very similar to the approach that I took for making those vents. But for example, you could have a raster image of your logo, which is I'm going to use right now here in a second. And I'm going to go ahead and stamp our logo on the brace and mark it. So once this finishes calculating, we'll do that. So now that that finished, I'll go ahead and just look at the part in this direction and come over to emboss area. Now emboss area is a very similar tool, and you see by default it has our logo, but you can go through and emboss with any of these images that are built right in, or even your own, like I mentioned before. And you can change the size using some shortcuts or even adjust it down here. And whatever wherever I tap the surface, whatever's blue is going to get offset the distance that I have set down here. So I'm going to say I want to offset negative 0.2 millimeters and then hit apply. So now I can basically just keep my company logo and kind of apply raster images to that surface. So now that I have the completed brace, this is what I had to show for today. I'll just rotate it around so you guys can see. And if I really wanted to, I can come over and change the color of this object as well. So if I select that object and I come over and make it the same color that we had for our preview image today, you can see that I could have changed that. And if you were printing it on a color printer, the colors do come across if you save this out as a PLY or an OBJ where colors come across. So that's my portion of today's demonstration. I believe now we're going to transition to a time of Q&A.